For those of you who have watched the Philips restoration episode, the chassis of the Aristona will look suspiciously familiar. And in fact, it is familiar because the Aristona is actually built by Philips, or I should say was built by Philips. Now, you'll also remember that the Philips BX230U chassis was quite crowded below, and as you can tell, the chassis of the Aristona is very crowded too. In fact, it's even more crowded than the Philips. Now, I even suspect, although I don't have the Philips with me any longer, that the actual chassis, the metal part I mean of the chassis, is the same as the Philips, aside from a few details. Now, there are a few electrolytics on this chassis. There's one here, and there's one there, this golden colored one. And on the other side there's also an electrolytic can, of which the foot of which you see here. So the electrolytic can is attached with a big nut to the underside of the chassis. And if you take a good look at the electrolytic, it will certainly look familiar to those of you who watched the Philips restoration. In fact, if I remember correctly, this electrolytic can is identical. There are two 50 microfarad capacitors in it, and the peak voltage for which it is rated is 280 volts. So yeah, interestingly enough, it is quite similar to the chassis of the Aristona. Now, the big difference between the Aristona, quite similar to the Philips, I mean to say. So, the big difference between the Aristona chassis and the Philips chassis is that the Philips was built to receive AM, long wave, and a short wave band, whereas the Aristona is built to receive FM, AM, and a long wave band. So, oh yeah, and another big difference with the Philips radio I restored is that it's not really built to amplify a pickup signal. You remember the Philips had a pickup input, the Aristona does not. Right, there are also quite a few IF cans, as you can see, on top of the chassis. There's this part is the FM. This is the FM IF part. This is the AM IF part. Interestingly enough, Philips, or well, I should say Aristona, mentions the local oscillator frequency for the AM IF frequency, which is 452 kilohertz, and they mention it by stamping it on the chassis. I don't know if that was common practice back then, but I've noticed this on several radios already. On the Grundig, there was the same thing. There was also a beat frequency, an IF local oscillator frequency mentioned, although it was slightly different from this one. And then there is the infamous power resistor, because remember, this radio is transformerless, So it takes its power directly from the AC. In fact, it rectifies the AC voltage to the necessary B plus voltage for the whole circuitry. And well, in the power supply circuitry, there's also this infamous resistor. It has different values though, and I suspect it also has only 2 resistors, whereas the one in the Philips had 3. Now, like I said just now, it has different values from the Philips. In the Philips it was a 180, a 200 and a 450 ohms, if I'm not mistaken. This is a 280 and a 160 ohms. I don't know if it's good. I haven't measured it yet, but I'll do that as soon as I'm done with replacing the capacitors in the electrolytic can you see here. In fact, I haven't measured out anything quite yet because I'm making an inventory first of all the capacitors and or resistors I might need in this radio. And so I'm having a close look first at what I might need to replace. I'll end up by saying that an interesting feature in this chassis is that they built in 2 little metal shields. They built one around the AC switch, and you see it here. So this metal shield, I think, was built in to protect the rest of the chassis circuitry from the AC power. So from arcing, AC power arcing, or sparks flying or anything like that. So yeah, it's an interesting safety feature. Also, around the IF part, the FM IF part, they built in a shielding, which you see here. And I think that is because they wanted to shield the FM part of the radio from high frequency noise, exterior high frequency noise, and possibly even from high frequency noise coming from the radio itself. So that's an interesting feature too. And lastly, I would mention that the dial illumination lamp, which you see here, this light bulb here, is also mounted on a piece of phenolic plastic, which you see here. But contrary to how it was built in the Philips, this one can't slide up or down, but it swivels. You see? It swivels around like this. And also, whereas in the Philips there was a PTC resistor mounted in parallel with the light bulb, here there's simply a normal power resistor built in parallel. I think the engineers at Philips did that to save a little bit of money, since a PTC or an NTC is always a little bit more expensive than a normal resistor. Right, the mechanical part, well, the mechanical part is easy. It doesn't need any restoration at all. It just probably needs a good cleaning, and that's it. So from that point of view, I'm lucky. You'll remember I had to repair the dial needle movement mechanism in the Philips. And well, in the Aristona it's intact. So this gives me a beautiful opportunity to observe how they built the mechanism, which might be interesting for future reference. In fact, I made plenty of pictures of it just for that. And I'll end up by saying, for now, that you'll notice on the chassis, let's see, yes, you notice on the chassis here, there are marked quite a few stamps. Now, there are Roman numerals here, 1, 2, 3. I think those stamps were put onto the chassis at every stage of construction. So these chassis moved probably on a construction line through the factory, and at every important stage, when a specific milestone was reached, a controller, a quality controller, put down a stamp. So this is interesting. Also, there are 2 oval stamps that I can see here, and I suppose these are burn-in test stamps. So they probably let the radio work for an hour or so, or maybe even longer, at the end of the construction line. And if the radio passed the test, they put a quality control, a final quality control stamp, or maybe even 2. So that's it for now. So the next thing I'll be doing is unmounting the electrolytic can you see here and replace the 2 capacitors inside. Then I'll probably measure the power resistor and a few other resistors, and when that is done, then I'll start replacing all the paper caps and mylar capacitors I find underneath the chassis. Before I'm going to test fire up the chassis of the Aristona, I decided I would give the chassis a cleaning, and you can see the result of part of the cleaning over there. As you can see, on your right, the chassis has been cleaned, and on the left, you see it is not. You see that yellowish stuff. Now, I think that this chassis must have been in a home of heavy smokers, and if I'm not mistaken, part of that grime you see on the chassis must also have been because the radio was probably near the kitchen. So it's very oily, it's dirty, it accumulated a lot of dust too. So what I'm going to do is to give the chassis a good cleaning. Well, the whole chassis is clean now, and I'm preparing to fire it up. The very first time since I have it, and probably the very first time after many years of not having played at all. Now, okay, I'm not pretending to say that the chassis looks squeaky clean, but it looks acceptable, reasonable. And, well, I might polish it a bit more, probably, but We'll do that once the moment comes that I will reassemble the whole radio. Now, I'm going to give you just a quick overlook of what I did to the chassis, because I know you are probably just as anxious as I am to fire up the radio and see what happens. So, okay, here it goes. I replaced the two electrolytics inside the electrolytic can you see here. Two 50 microfarad capacitors, 250 to 280 volts. Now, I did what I did when I restored the Philips BX230U. I gutted the electrolytic can, and once I pulled out the old electrolytics, I just put in two new electrolytics and soldered their contacts to, or their leads to, the contacts of the old electrolytic. Now, to do that, I had to drill two small holes, two tiny little holes, just wide enough to pass the leads of the new electrolytics. If you want to have an idea of what of how such an electrolytic looks like on the inside, then I would advise you to take a peek at one of the episodes of Restoring the Philips, because this electrolytic is identical to the one in the Philips. So there you go. Okay, so I cleaned the tubes as well as I could, and one note about that: beware if you clean vacuum tubes, alright? Because the lettering on those tubes is very, very weak. Yeah, it was already faint on some of the tubes, and really even a simple rub with your fingertip might rub off the lettering. So I'd advise to clean around the lettering, not over it, and I used cleaning petrol to clean the rest of the tubes. You know, something like this. Yeah, so this is cleaning petrol, which they use to clean dirt spots out of clothes, or maybe from furniture or stuff like that. It evaporates rather quickly, and it doesn't leave dirt traces or anything. It's also not too expensive. I think I paid about $4 for a bottle of 1 liter. Yeah, so yeah, there you go. Buy yourself a bottle of cleaning petrol. Right. What did I do else topside? Oh yeah, I measured the power resistor you see here. Now, the power resistor consists of two resistors. As you can see, let me see if I can make it close up. One of the resistors, if you look at it like this, if I can make it focus, okay. So the left resistor is 280 ohms and the right one is 160 ohms. Now, I measured them both, and the one of 160 ohms, so the one on this side, yeah, measures practically bang on. It was, if I'm not mistaken, 163 ohms. So that's pretty good. The other one, though, is not so good. it measured about 325 ohms, which is, well, close to, let's say, between 10 and 15% over its intended value. Not bad if you take into account, let's say, an error margin of 10 or 15%. That's okay. So there you go. I measured it. It's a bit high, but I think it's still functional. Right, then I measured this power resistor here, and it has no markings. At least none that I can make out. I measured it. It measures a little bit over 1 kilo ohm. If I'm not mistaken, about 1035 ohms. And according to the schematic, it should be exactly 1 kilo ohm. So that's fairly good. Strangely enough, I don't know why they marked that resistor separately on the schematic. In fact, if you look at the schematic, you see it right there. Okay, so this is a resistor that I showed you just now. Yeah. Now, why would they mark that separately? I don't know. Now, you see here +2, +3. Yeah. And if you look here, you see +2, +3. Now, this is one part of the B+ voltage. And if I'm not mistaken, the voltage it outputs is 160 volts. Now the other B+ voltage you see over there is 200 volts. So that's what some people would call the B++ voltage. Okay, so the 200 volts line, which is this line, is the B++, and this is the B+ voltage. Oh yeah, one interesting little detail, as the schematic shows, all the filaments are series coupled. So you see them here. There are 6 tubes in this radio, so you have 1, 2, 3, 4, 5 and 6 filaments. And like I just said, they are all connected in series. This little symbol here is the dial illumination lamp. This one over there. Now I measured it out. There's still continuity, so it should work properly when I fire up the radio. By the way, a very interesting little detail are these two symbols here. Now it turns out Philips mounted PTCs over the dial light bulb. In fact, what they did, I don't know why they did that. On the schematic, one of the PTCs is parallel with the light bulb, and then you see a resistor here. Don't ask me exactly what the value is. I'm not sure, it's 300 ohms or something like that. I need to have a look to be sure, but in any case, they interchanged these two. So instead of mounting this resistor in series with the light bulb and then putting a PTC in parallel, they put the PTC in series with the other one and the resistor parallel with the light bulb. I imagine they did that to provide a permanent shunt over the light bulb to reduce the amount of current running through it, I think. Also, you see there are two filaments in series with the light bulb. And if I'm not mistaken, one of these filaments is even of the rectifier tube. Okay, so it is a bit peculiar to put two filaments in parallel with the dial light bulb, but I imagine they did that because they used it as a sort of a safety feature. Yeah, if the light bulb burns, well, there might be less current going through the two filaments. I'm not entirely sure, but okay, a PTC. For those of you who are not familiar with this, there are two kinds of heat sensitive resistors. There are NTCs and PTCs. NTC stands for negative temperature coefficient, PTCs for positive temperature coefficient. Now, NTCs, when they heat up, their resistance drops. Yeah, PTCs, on the other hand, as they heat up, their resistance becomes higher. Now, why exactly Philips did that, I am not entirely sure. Now, the fact is, of course, when the filaments are cold, they draw a lot more current. And since these two are PTCs, that means that their resistance is low when they are cold. So they allow these tube filaments to heat up quickly. Which means, in theory, I believe, that the radio would start up a little bit faster. At least that's my theory. You might not agree with me, but I think that's what it is. Okay, so let's get on with it. Well, okay, top side, I cleaned also the tuning capacitor. I put a touch of grease on the ball bearings of the tuning capacitor, namely over there, yeah, where I'm pointing, there, and at the back over there. I put some grease, and now it turns over rather easy. If I can make at least my camera focus a little bit. So now it turns over rather easily. Yeah. It's still not extremely smooth, but I guess with a little bit of extra cleaning, I think I can make it really smooth. Okay, I also sprayed contact cleaner in the tuning capacitor. I did the same with the volume knob, which is, by the way, also the on-off switch, as you can hear. And oh yeah, by the way, remember this little screw you see here on the shaft, the volume knob shaft? Well, it's exactly what I thought it was. You see, Philips, let me show you. Philips probably used, well, this is an Aristona, but it was built in a Philips factory. Philips probably used standard volume knobs for all its radios. And as you can see, to be able to use a standard volume knob like this in many more types of their radios, they had to mill a separate little axle like this to be able to fit a knob onto the volume axle. And it's quite nifty actually. They milled out a rod of steel, so you can see it's completely hollow, and they slightly milled off a part of the axle of the volume knob, and in such a way that this extension slides over it like this, and then both are attached with a tiny little screw, the one you see here. So let me screw it back. Okay, there we go. So yeah, it's a quite nifty little trick they used to reduce the number of parts they had to fabricate for assembling radios. Oh yeah, by the way, the two PTCs on the schematic for the dial light are those two here. These two are the two PTCs on the schematic. Okay, right. Okay, that's about top side. Well, okay, I also cleaned more or less the IF cans and all that. So what did I do? Bottom side. Let me see if I can turn this over. Whoa. Take it easy. Right. Okay. So, as you can see, hang on. As you can see, or maybe you don't see, but I did replace a few capacitors. Well, one thing you do see probably is, hang on, okay, one moment. Okay, so one thing you do see is, one of the electrolytics that needed to be replaced is this one down there. It's a 100 microfarad, and I replaced it with a brand new one. Well, so that's okay. This one was a 5 microfarad originally. I replaced it with a 4.7 microfarad. That should work out fine. And then I changed a whole variety of paper caps. Yeah, you see these are replacements, that is a replacement, there's a replacement over here. Well, there are these two are also replacements, and this one is, and that one is. So I replaced a whole bunch of capacitors. There are still a few of the original capacitors in the chassis, but they are Mylar capacitors, like this one over here. Now, I read a little bit about these capacitors, and there's one down there too. Now, Mylar capacitors don't go bad that often or that quickly, especially if they are not overloaded. So, well, and I'll admit that replacing these capacitors down here in this part of the radio, well, is hellish. And if I can avoid at all to to have to solder inside this part of the radio, then, well, I'll probably you'll agree with me that I would prefer not to do that, okay? Because as you can see, the density of parts is really high. So, well, I wanted to avoid any possible damage by soldering deep down inside those parts. Changing capacitors inside this radio was already quite a trick, let's say, because it's, like I said, it's really so dense with parts that you really have to move cautiously. Okay, well, I did a little bit of cleaning here and there, and as you can see, the chassis is fairly clean underneath. The only thing I need to do is I still need to mount a fuse. Well, as you know, I always mount a fuse inside an appliance which has no fuse at all. Well, certainly an appliance that works on AC power. So yeah, I'm going to mount a fuse holder, and I'm probably going to mount it somewhere here, close to the on-off switch underneath the chassis. Okay, well, I think that's about it. There are no more special things to mention, so I think we should starting up the radio a try. Here it goes. Okay, I set the volume on maximum. Now I'm going to turn up the variac to, I would say roughly 1/4 of AC power, just to see. Okay, here we go. Okay, we're about at 1/4 of AC power. And I can't say I'm seeing much. Let's see. Well, at least there's no smoke coming off it, so that's okay. So let's turn up the voltage a little bit, say about halfway. Ah, yes, now I'm seeing glow. The dial light is glowing. Okay, hang on, let me take the camera. So the dial light is glowing. Excuse me. But I can't hear anything from the speaker, and also I can't see if the tubes are glowing or not. So no hum. Okay, so anyway, that's not a bad sign. Let's turn up the power a little bit. Okay, so here we go. I'm going to turn it up, say 3/4. Okay. Well, as expected, the dial light starts to glow a bit brighter, and yeah, I can see at least one tube where the filament glows. Yeah, that one over there. It's too faint for you guys to see it, but okay, I can see it. There are at least 2 filaments glowing. 3 filaments. 4. Can't see whether that one glows. 5. Okay, there's one I can't tell whether it glows or not. This one here. I can't tell, but the others glow. Okay, so let's put full power on it. Yes, there's crackling coming from the speaker. Whoa. Okay. Well, the amplification seems to work fine. So let's see. I can't tell on which band I am, so it might be the long wave band, it might be the FM band. So remember, this radio hasn't had an alignment yet, so I thought I heard something. Ah, yes. Okay. I think this is the FM band. Oh yes. Yes, this is most definitely the FM band. But reception is intermittent. I don't know why that is. The volume seems to jump up and down a bit. Why that is, I don't know. But I don't know why the radio is behaving so peculiarly. But okay, it's a victory of sorts, because, well, it seems to work. Granted, it doesn't work perfectly, but it does work. So, yeah, let's say it's a victory. Now, I'm not getting any sound at all. Let's try another band. This is the AM band. It's a very weird kind of wobble in the sound, you know. Loud, quiet, loud, quiet, loud, quiet. It's really weird. And that's a German radio station. Yeah, and the tone switch works too. This is low. This is high tone. Nice. Okay, that's a Dutch radio station. That's a French radio station. Okay.
Listen, you're coming from such a selfish point of view because you don't realise. You're selfish. Listen, we haven't had it for 5 weeks. You're selfish. Tony.
Okay, this is an Irish radio station.
Just get on giving me my point of view. You tell all fans to phone up and give us your point of view, and that's what I'm doing.
Okay. They were having a fight on radio. Yeah, on air, which is a little bit weird, but okay. Well, the quality of the sound is not really good. I think reception is fairly good, but the sound is not good at all. It fluctuates and it's distorted, so something must be provoking the distortion. It might be a weak output tube, but it might also be a faulty component. If you look at the schematic, yeah, you see there is a pentode in the amplification circuit there, and it might be that this pentode is acting up. You know, it's the UL41, or it might be the preamplifier, which is a part of the UABC80. You know, as you can see, it's a triode. Yeah, a triode. You see one part of the UABC80 is here, and then the other part is here, and this is a diode. Now I think this circuit here is the automatic volume control. So I think part of the problem might be either here or somewhere in the amplification circuit here. I don't know where the fault is, but we'll have to look for it once we're done with testing. Okay, let's just get on with it. Okay, and there's strangely enough, when I reduce the volume to very low volume, the quality of the sound is much better. Maybe it's simply just a problem with the potentiometer, the volume potentiometer. No, there's still distortion. No, there's still distortion. Much less, but there is distortion. Okay, so it probably is a problem in the amplification circuit. By the way, this power resistor here is kicking out quite a bit of heat. So in fact, this whole part of the circuit here is really hot. I can feel the heat rising. This is really hot. The rest of the radio is fairly cool. Okay, I can still feel some heat rising up here too, but here this part is really hot. Okay, so okay, that's a German radio station. Okay, that's it. Okay, now let's check the long wave. Okay. Okay, there's the second transmitter. Aha, that's a French transmitter, okay. Okay, 3 transmitters on the long wave. That's it. Okay. Well, the FM part of the radio doesn't work too well. In fact, right now it doesn't work at all. That's not so good. So I might need to fix that. No, the FM part of the radio doesn't work at all well, so we'll need to do some work on that. Okay, so what's the conclusion? Well, the conclusion is the radio functions. The radio functions well. Much better than I expected it would be, but it's not perfect. Okay, the sound is distorted. The FM band on the radio doesn't work very well. Well, in fact, right now it doesn't work at all. So, yeah, we still have some work to do on the radio. But all in all, I'm pleased, and I hope you are pleased too. Because we made the radio work for the very first time, probably in many years. Okay, so that's it for now.